Hey guys, welcome to STEMsational. Today I'll be explaining the concept of momentum to all of you. So looking at the specification, this is part of the triple content section for IGCSE Physics at Excel. So we will first cover the first formula for momentum that is covered in this specification, which is the following. So as shown earlier on the specification, the following formula that you guys need to know is momentum equals mass multiplied by velocity or more easily known as P equals mv. So you guys should already note that the unit for mass is in kilograms and the unit for velocity is in meters per second. So we can derive that because momentum is mass multiplied by velocity, then its units will also multiply. So therefore, the unit for momentum would be in kilograms meters per second. Okay, so you guys should also know that momentum is a vector quantity, so it has both magnitude and direction. Okay, so let's say that an object is traveling to the right at a speed of 5 meters per second, and let's say that its mass is 10 kilograms. So using the equation above, we can derive that its momentum is therefore 50 kilogram meters per second. However, let's say that instead the object is traveling to the left direction. So therefore it's traveling backwards, and it has the same mass and the same magnitude for its velocity. But we know that if an object is traveling to the left direction, therefore its velocity would have a negative value, so it would be negative 5 meters per second. So when we use again the above equation, we can derive that its momentum is negative 50 kilogram meters per second, as we have to account for its direction, considering that momentum is a vector quantity. Okay, so looking back at this specification, the next concept that I'll be explaining is 127, which is the conservation of momentum. Okay, so now we can use the conservation of momentum principle to solve questions like these. So you guys can try solving this question yourself first by pausing the video and unpause it for an explanation. Okay, so a boy of mass 43.2 kilograms runs and jumps onto a stationary skateboard. The boy lands on the skateboard with a horizontal velocity of 4.1 meters per second. So we first need to state the relationship between momentum, mass, and velocity, which we know is just momentum equals mass times velocity. Part 2 states that the skateboard has a mass of 2.5 kilograms, and using ideas about conservation of momentum, calculate the combined velocity of the boy and the skateboard just after the boy lands on it. Okay, so we know that conservation of momentum is just momentum before a collision is equal to the momentum after a collision. So the momentum before this collision would be the boy's momentum plus the skateboard's momentum. So let's say that the boy's momentum is m1v1 plus the skateboard's momentum of m2v2. And because after a collision, the boy and the skateboard would be moving in conjunction, so that means that the boy and the skateboard would have a combined mass, so m1 plus m2, and they'll be moving at a new velocity of v3. Okay, so using this equation, we can just plug in values. So we know that the boy's mass is 43.2 kilograms, and we can multiply that by the boy's velocity of 4.1 meters per second, and we can add that to the skateboard momentum of its mass is 2.5 kilograms. We can multiply that by its velocity, and because it's stationary, that means its velocity would be 0. And that should equal the boy's mass, which is 43.2, plus the skateboard's mass of 2.5 kilograms times the new velocity that we're looking for. Okay, so using my calculator, the boy's momentum is 177.12 plus the skateboard's momentum is 0. And that's because its velocity is 0 So that means that it has 0 momentum. And that should equal 45.7 kilograms, which is the combined mass, times the new velocity. Okay, so to find new velocity, all we need to do is just divide the boy's momentum by the combined mass of the boy and the skateboard, because as we can see from this equation, 45.7 times the new velocity is equal to 177.12, which is the boy's momentum. So all we need to do is divide the two values to find new velocity. So the new velocity is just 3.9 meters per second. So now let's look at 128, which states the equation of force equals to change in momentum divided by time taken. Okay, so what you guys need to know about this equation is basically just force equals to the change in momentum, which is basically just the final momentum, which is mv, minus the initial momentum, which is mu. So v here is the final velocity and u is the initial velocity. And you divide that by the total time taken of the collision. Okay, so with the following equation, we can solve these types of questions. So this question states that a driver has a mass of 67 kilograms and drives at a velocity of 15 meters per second. The car is involved in a crash. The driver is wearing a seatbelt and comes to rest in 0.36 seconds. So part I just asks us to state the equation, which we know is force equals change in momentum divided by time taken. Okay, now you guys can try solving part II and the next part after that by yourself first by pausing this video and unpausing for an explanation. Okay, so to do part II, we can use the equation above to prove that the driver's force is about 2,800 newtons. So let's write it down first. The change in momentum is mv minus mu divided by time taken. And that should equal approximately 2,800 newtons. Okay, so now that we got our equation down, we need to find the values for mv and mu. So mu, that would equal 67, which is the driver's mass, times 15. The question states that the driver drives at a velocity of 15 meters per second before coming to a crash. So that means that would be the initial velocity that the driver is speeding towards. Okay, for mv, that would be 67 as the mass would remain the same. And we'll multiply that by 0, as the question states that the driver is involved in a crash. That means the driver's velocity would decelerate and come to 0. And the time taken we know is 0.36 seconds. So now we can just plug these values into the equation. So 67 times 0 minus 67 times 15 divided by 0.36. So just solving that, 67 times 0 is 0, 0 minus 67 times 15, which is, let me type that in my calculator, 1005. Oop. Divided by 0.36 seconds. So 1005 divided by 0.36 equals negative 2,792. Now we can just ignore the negative sign and take the absolute value of that, which is 2,792. And that is approximately 2,800 newtons. Okay, so part 3 states that a passenger of the same mass as the driver is also in the car at this time of the crash. They were not wearing a seatbelt and experienced impact force that was 5 times greater than the force experienced by the driver. So we need to calculate the time taken by the passenger to come to a stop. Okay, so again we can use the mv minus mu, which is change in momentum, divided by time taken equals force equation. Okay, so at first we need to find the change in momentum of the passenger. We know that the passenger's mass is the same as the mass of the driver as stated in the question. So the passenger's mass would be 67. And now, because the passenger is stated to also be in the car at the time of the crash, that means the passenger and the driver would be moving at these exact same velocities. That is because they are both part of the same car and the car moves at a certain velocity. So the passenger's initial velocity would again be the same as the driver's initial velocity, which is 15 meters per second. And the passenger's final velocity would also be the same as the driver's final velocity, which we know is 0 meters per second. So we can just plug in these values into the equation, which would mean that the passenger's change in momentum is equal to the driver's change in momentum, which we have already found above is negative 1005, but we can ignore the negative sign, so 1005 divided by the time taken, which we are looking for, would equal to the force. Now the question states that the force experienced by the passenger is 5 times greater than the force experienced by the driver. So we found above that the force experienced by the driver is 2,792 newtons. So we can just multiply that by 5, as the passenger was stated to experience a force that was 5 times greater than 2,792. Okay, now that we have our equation all set up, we just need to solve for t, which is the time taken. So t would equal 1005 divided by 2,792 times 5. So we can use our calculators. So the time taken would equal 0.072 seconds. Finally, let's look at 126, which is the idea of momentum to explain safety features. So the safety features that are implemented in cars to prevent injuries in car accidents, such as crumple zones, seatbelts, and airbags, all perform the same thing. The way that these features prevent fatal injuries has to do with the force equals change in momentum over time equation. So in a car crash, we know that the final momentum of the car would be 0, as the car decelerates to 0 velocity in an instant. Like let's say that before a crash, a car is moving at a velocity of, let's say, 5 meters per second. And after it crashes with a wall, let's draw a wall there, its velocity definitely becomes 0 meters per second, as the car is not moving. And this deceleration from 5 meters per second to 0 meters per second happens in a very short period of time. So the idea is that these safety features increase the time taken for that change in momentum to occur, because these features crumple, stretch, or compress. Like for example, let's say that a car without airbags has a change in momentum of 6 during a car crash and takes 1 second, so the time is 1, for the momentum to decrease to 0. While the same car with airbags, so this one has airbags, with the same momentum of 6, would take 2 seconds, so the time taken is 2, for the momentum to change to 0. So without airbags, the car would exert a force of 6 over 1, which is 6 newtons, while with airbags, the force is 3 newtons. So as shown by this example, increasing the time taken would result in a smaller value for the force, and less force means that there is less force acted upon car passengers, which reduces injuries. Okay, so you guys can try solving this full past paper question yourselves first by pausing the video and unpausing for an explanation. Okay, so part 2a states that an ice skater throws a 0.23 kilogram snowball with a velocity of 13 meters per second. So we need to first state the equation, which is just momentum equals mass times velocity. Okay, now we need to calculate the momentum of the snowball. So we know that the snowball's mass is 0.23 kilograms, so we can just multiply that by its velocity of 13 meters per second, which gives us 3 kilogram meters per second. And that's its momentum. So the answer is 3. Okay, so part 2b states that when the skater throws his snowball forwards, she slides backwards on the ice, and we need to explain why she moves in this direction. So this is the model answer I came up with, because due to the conservation of momentum, the combined final momentum after the skate. Okay, so part 2c states that the skater wears soft knee pads that compress easily, and we need to explain how the pads protect her knees when she falls on the ice. So I said that the pads increase the time of impact, so the same change in momentum divided by a greater time reduces the force on her knees. Thanks for watching, guys. Don't forget to like and comment down below on this video, as well as our other videos on this channel, and please subscribe, and good luck on your exams.